Okay, so this should be everything you need to know about Lab 4. First, I'm going to go over for loops, then printing a variable number of spaces, and then printing out the nth digit from an integer. So first, let's go over for loops. You want to use for loops every time you want to run a piece of code a certain number of times, or you want to run a piece of code multiple times with a counter, usually. Anything you do a for loop for can also be accomplished with a while loop, but sometimes a for loop makes the syntax a little easier. So your basic for loop is going to start with an iterator that I'm going to set equal to 0 in the first spot. Next, I'm going to say run it until I is equal to a certain number, and then I'm going to increment that iterator. So for example, this would run the contents here 10 times. So if I did this, I get here 10 times, and I can also print out the value of I. There we go. So we can put any code in here and it will run 10 times. A couple notes about the for loop is, while this is the most common example you'll see, you don't necessarily need to have it take this form. So for example, I can put a print statement for here if I were so inclined. That's just to highlight that any code can go right here. It's going to run once. Any code can also go here, or any statement, any single statement can go in these spots. And this is going to run after the contents of the loop. And then anything that evaluates to a true or false value goes right here. So if I were to put 1 here, that's going to be true. Then this loop would just continue to run. So the loop only stops when this evaluates to false. But this is going to be the most common way you use it. And like I said, I can put any code in here. So for example, I can put another for loop in here. And of course, I have to change the iterator out to a new variable and declare it. And then if I want to print out both of these, I can do ij, and I'll just lower this down to 3. And we can see that the outer loop iterates slowest, while the inner loop iterates every loop, or every line of the print statement. So we see how j is going up first, and then I goes up once because the body is being looped inside the outside. Okay, so that's for loops. That should get you through this lab. Next, I'm going to go through variable spacing. So let's say I have a print statement. I want to print here, and I want a variable number of spaces right here. So right there, I have 3 spaces. Let's say I want to have a variable number of spaces in front of the here. There's a few ways you can do this. The first is with a simple for loop. So let's say I have a variable called space count, and I want to set that equal to 5. Now I'd want to print 5 spaces right here. So I could do that with a for loop. First, I would need to declare my iterator. Oops, I is less than space count. And then I could do a simple print statement where I just print spaces every time. So every time this for loop runs, I would print 1 space. A quick note about this for loop is, notice how I've not included this first part. If I were to just do this, then I could do that. But because I've declared I out here, I don't actually need anything in the front there. In fact, you don't need any of this. So for example, if I were to do this, this would just run forever. Okay, so let's see this run. There we go. I have 5 spaces, and I can increase this to 15. There we go. This is the most straightforward way to do it, but I'm not sure I would recommend this way. There is a better way using printf itself. So what we can do is do a %s. Now this is a string placeholder. And as we learned last lab, we can pad out a double or one of these placeholders to a specific amount. So if I were to put 0.5 here, let me put just 5 there. Oh, of course. So I use the string placeholder, but I need to give it a string. So I'll just give it an empty string for now. There we go. That looks a little better. So now we can see I have 5 spaces here. If I were to increase this to 15, I now have 15 spaces here, but I'm hard coding this 15 here. So what we can do is actually make this also a placeholder. By making this a star, what it will do is it will look in just before whatever. So for example, this string placeholder is being filled by this empty string. Just before that, I can put a number right here. So this 5 will then be put into this star place. So now if I run that, we see I have 5 spaces, and I can swap that out for space count. And now I have a variable number of spaces. Let's actually combine these two things. And instead of having space count, I'll do I. Make sure to declare I. And we can see how every line of the print statement adds one more space to this, or every line of the for loop adds one more space to this print statement. All right, now moving on to the nth digit. Let's say I have an integer, 1, 2, 3, 4, 5. I'll just call it num. And let's say I want to get the digit at each one of these places. So I want to be able to get 2 from the 4th place. So you guys should all know about the modulus operator. If I do num mod 10, that will get me the 1st place. We see I get 5. If I do mod 100, that will get me the 2nd place, but it will give me 2 numbers. So that's going to give me mod 100 is of course going to be the first 2 numbers here. And let's say I just want this 4. Well, looking at the number that's given back to us, 45, we can see that, well, if I just divide that number by 10, I'll get the 4. So what I can do is divide by 10. And there's my 4. And now if I want to get the 3, I would add a 0 here, add a 0 there. Now I get the 3. So we can see a pattern here. As we move over the digits, I want to continue to add zeros here. And we see I have 1 fewer 0 on this side than on this side. And then if I go past the end, I get 0. And this makes sense because if this mod number is bigger than the number itself, I'm just get the whole number back. And then when I divide by a number that's also bigger than this number, I'm just going to get 0. So any digits that are in front of this number turn out to be 0. Okay, but now how do we get the nth digit? Well, let's say I have n is equal to 3. Well, let's establish which digit that is. So I'll say it's going to be the 3. So in order to get that, I would have to do 1,000 and 100 there. Let's just establish that. Yep, it's a 3. So if I want to get the 3, in this case, we see I have 10 to the power of 3 right there. So this is 10 multiplied by itself 3 times. I think I can double check that. But I can use the pow function in order to accomplish that. The pow function comes in the math library. Oops. So I would want to include math.h here. And also an important note when I compile it is when I compile, instead of doing it's main.c-o main, instead of just running this, I need to add -lm to it. And that's to link the math library. You only have to do this with the math library, but every time you use the math library, you need to link the math, link it like this when you compile it. And the error that will show up if you don't do it is it will say pow is not defined. Okay, so it looks like pow returns a float. So I need to first cast that as an integer. There we go. And now let's run it and just see. Yes, 3. So this can be replaced with n. And then what I can do here is we know that it's going to be n minus 1. So I can just copy this and n minus 1. Zoom that out a little bit. So we see now that instead of hard coding those large numbers in, I now have 10 to the power of n and 10 to the power of n minus 1. And now I can change n to whatever I want. If I want the 2, this should give me the 4. If I want the 1, that would give me the 5. And this is how I get the nth digit. And similar to the last example, let's just put this in a for loop real quick. Declare our iterator out here. And let's go 5, because that's how many digits we have. And instead of n, let's do I. And let's start it at 1. There we go. So I get 5, 4, 3, 2, and I'll run it one more time. There we go, 5, 4, 3, 2, 1. So that's getting the nth digit from an integer. All right, that should be everything you need to know to complete the lab. Best of luck with it.